Good evening, class. I am Mohit, TA for this Electronic Theory of Solids course. This is our fourth number class, and in today's class, I'll be solving the assignment number 3, problems which are related to it and which might be useful for you guys for the perspective of your exams, either midterm or final term. And this will give you an idea over the numericals and some derivations which has been done in the classroom by Professor Aragya. And so I'll start from the question number 1, which says that there's a wave function psi which is 1 by root 2 times phi 1 psi is there, which is 1 by root 2 times phi 1 plus 1 by root 5 times phi 2 plus 1 by root 10 times phi 3. So this is the given wave function, which is a combination of three different wave functions, phi 1, phi 2, and phi 3. And the question says that the three wave functions, phi i's, are orthonormal to each other. What does it mean is that phi I, phi j will be delta ij. That is, for I is equals to j, it will be 1. Otherwise, it will be 0. That's what it means. Now they have given a Hamiltonian operator h cap, which when gets operated on wave function phi n gives n squared times phi n. That is, there's an operator Hamiltonian which gives the value n squared times phi n. Okay. Now the question asks is, what is the expectation value of a Hamiltonian h cap? So we know expectation value of an operator h cap will be psi h cap psi and then divided by normalization factor psi and psi. Yeah, this type of is known as ket. This is bra, and this is your Hamiltonian operator. But yeah, now let's just calculate. So the expectation value of h we write like this. Let's just operate first h on psi. Let's just first calculate this part, h on psi. This will give us 1 square by root 2 times phi 1 plus 2 square by root 5 phi 2 plus 3 square phi 3 by root 2. This 1 square, 2 square, 3 square comes because this is 1, this is 2, and this is 3. And the Hamiltonian operated on phi n is n square. So that's why these numbers. Now, what is this psi h psi? So it will be phi 1 by root 2 plus phi 2 by root 2, 5 plus phi 3 by root 10, and it will go and club with phi 1 by root 2 plus 4 by root 5 phi 2 plus 9 by root 10 phi 3. Okay. Remember, phi i's are orthonormal. So this will be phi 1 times phi 1 will be 1. So let me just write, those who don't know, it will be 1 or 0. If I is equals to j and I not equal to j, this value will be 0. That's what it means. So this will give phi 1 is 1 by 2 plus 4 by 5 plus 9 by 10. This is the first term, numerator. Numerator of, let me call this equation 1. Equation 1, we have calculated. Now let's calculate the denominator. So the denominator will be pi, and that will be phi 1 by root 2 plus phi 2 by root 5 plus phi 3 by root 10 times phi 1 by root 2 plus phi 2 by root 5 plus phi 3 by root 10. And this is known as a, like, calculating the normalizing factor, this process, and this will be 1 by 2 plus 1 by 5 plus 1 by 10. So let's just calculate this number. So 5 and 7, 7 by 10 plus 8, 8 by 10. So this will be 8 by 10. And I can calculate the numerator also. So let me just simplify this one further. This is 5 and this is 8. 5 and 8 will be 13 plus 9 will be 21 by 10. 21 or this should be 22. Should be 22, I think. Let me just see it again. 5 and 8. 13 plus 9 will be 22. 22 by 10. Yeah. So expectation value will be psi Hamiltonian. So this is equation 2 and this is equation 3. This is equation 2 and 3. Let's compare it with equation 1, which says that the expectation value of an operator h will be psi h psi by the normalizing factor. So if you do it, so we'll get 22 by, this will be psi, it's kept psi by this normalizing factor. And if you compare that equation, it will be 22 by 8. Can divide it by 4, 11 by 4. This will be the answer. Okay. And let's just look at the options. Which are the options there? So if you see it, the first option is 11 by 10, the second is 11 by 4. So the question which was asked in the very first question is like the wave function is given psi, which is a linear combination of three different wave functions phi1, phi2, and phi3. These functions are orthonormal with respect to each other. Orthonormal means psi I, psi j will be delta ij, where this will be 1 or 0 depending if I is equals to j and I not equals to j. That means that psi1 will be 1, psi2 will be 1, and similarly psi3, but psi1 and psi2 will be 0. That's what it means. And the Hamiltonian is given, which gives that if it gets operated on the wave function phi n, it gives n square times phi n. So if it gets operated on phi 1, it will give 1 square. If it gets operated on phi 2, it will give 2 square. If it gets operated on phi 3, it will give 3 square. That's what happens here, these terms. So the psi is calculated, expectation value of h, and expectation value of operator is given by this relation. The bottom part is for the normalization factor. So the first term is like this if you operate it. The second is the normalization factor is this 8 by 10. Substitute these 2 and 3 here, and what you get is 11 by 4. So that's the first question. Now coming to the second question, which is the following Breville lattice exist as a phase-centered unit cell. Okay, so let's look at what does the phase-centered unit cell mean first, and then what are the different these orthorhombic, monoclinic, and tetragonal. And I'll come to these like one by one. So if I draw simple cube kind of thing, okay, fine, this is also good. So in a primitive unit cell, in a simple unit cell, what happens? The atoms are at the corner. This is a simple cubic. In face center, there will be an atom at each face. Like this is the face, right? This is also a face. Similarly, all the faces are there, right? For the cube. So each atom at the face center. So there will be a total of 6 faces. And this will be equally shared by one the unit cell and the another on the other side. So that's what the face-centered unit cell mean. Now coming to the orthorhombic. The orthorhombic is the one where if this is your A, we call this one as A, this one as B, and this one as C. Let me call these are the 3 sides of the cube of a cuboid. Cuboid is there. Okay? So orthorhombic is the one in which A is not equals to B is not equals to C, but the angle between A and B, this angle, basically this angle between A and B is alpha, B and C is beta, and C and A is gamma. But alpha is equals to beta is equals to gamma is equals to 90 degree. So this figure. So in this case, yes, it is possible to have the simple cubic also, the red circles, which you see the simple cubic, and the face centered also possible here. The red, these purple one which you see, these ones, these purple one which you see, they are like, let me just shade them. So these the purple one, the 6 purple, they are the face centered. So yes, it is possible in the orthorhombic. Now comes the monoclinic. In monoclinic, what happens? A will not be equals to B, will not be equals to C, but here alpha and gamma will be 90 degree, but beta won't be 90 degree. It will be something different. So you can think it like a some tilted structure where angle between A and B is 90 degree. Angle between A and C is 90 degree, but angle between B and C is not 90 degree. So that's what it means. And in that case, as you can see that the system requires a symmetry to have this face centered. So in this one, only the simple cubic is possible. Base centered, yeah, the base centered is possible, but FC face centered is not possible. Now coming to the third option, which is there, is tetragonal. Tetragonal is the one in which A will be equals to B, but not equals to C. And in that case, alpha will be beta equals to gamma equals to 90 degree. In this case, since alpha and beta and gamma are 90 degree, and so does the face centered is possible here in this case. Face centered is possible, but just by doing a translation, by doing a translation, it can be reduced to body centered. If it can be reduced to body centered, so the body centered is more preferable over the face centered because more of the symmetry, and that's why the FCC is not possible in the tetragonal because it can be written in terms of the body centered. So the only answer which complies with the uh, given options is orthorhombic. So the correct option should be the orthorhombic. If any question or doubt is there, you can ask the chat box. I'll be answering this. Okay. If no more question, then I will move on to the next question, which is the two-dimensional lattice of a graphene in an arrangement of carbon atoms forming a honeycomb lattice of lattice spacing A as shown below. The carbon atoms occupy the vertices. The Wigner side cell has an area. Okay, cool. So yeah, now coming to this. This is the lattice of the graphene, which is a honeycomb lattice. This itself is not a graphene lattice, is not a Bravais lattice, but it is made up of the two Bravais lattices. Basically, two atoms in a unit cell will be there, and that's how it is made of. Now, coming to the question which has been asked, what is the Wigner side cell in this given scenario? So, A is the lattice constant, is the distance between the neighboring carbon atoms. So, this is A. So, I will take this cell and zoom it here. So you can see if I write this one as 0 0, and so this I take this axis as my x, this as my y, and that's an individual choice. You can take some different axes that will also give you the same results. The physics essentially won't change. So this is my x, this is my y. So I define this point as 0, 0. So this will be my a0, basically. Now I know that if in this case, if I have to choose the Breve lattice, it will be like this. You can choose some different unit cell, but this, if you repeat this one or a repeated period, then it will give you the unit cell. So for example, this is, I have already copied it. So I'll just take it and paste it. Let me just copy it, paste. So I'll keep it here. Copy and paste. So if I do it like this, the geometry will get repeated. And that's what the probability mean. Right? So if I do it, the shape I have not done perfect, but if you do it, you will find that, okay, this can be repeated at the, so yeah, let me do it. So the same shape can, if you compile it, you can generate a full lattice out of it. That's what it essentially means. For example, here, this is not very perfect, but this will be exactly, it should be at the center. Like here it is at the center. It should be here at the center. This should be here at the center. Like if I draw it properly, the geometrical kind of thing, this will also come at the center. So each one will have one atom at the center and the rest 4 at the corner. At the corner. And each corner will be shared with how many unit cell? 1, 2, 3. So each one will be shared with 3 unit cell. And in that case, that will be 1 by 3 and then one carbon atom at the center. Okay. So if I can compute this B1 and B2, and then I can compute this area of this one by using B1 cross B2, the area, right? And that's what I'll be doing. So I'll define this 0, 0 and A0. The bigger side cell is just the primitive unit cell, basically, the real space. So it's 0, 0 and 1, 0. So if I have to calculate the coordinate of this point, then this is 30°. This complete will be, I think, 120°. If I take this one, this will be 120. If I make 90° out of it, so the remaining will be 30°. This is 30°. This is, the other will be 60°, and here it will be a 90°. This will be a perpendicular. So if I take cos theta, cos of 30°, that will be, we call this length as x, not x, let me call it at maybe capital A, and this as capital B. So then capital A by this length is already A. We know in the given question this length is A. Which length? This length is already A. So cos 30° will be A by A. That will give the A to be root 3A by 2. Similarly, the B can be calculated and B will be 3A by 2. So the coordinate of this point will be AB, and that will be 3A by 2, root 3A by 2, 3A by 2 and root 3A by 2. Okay, sorry, it should be BA. Coordinate should be X and Y, not Y and X. So the coordinate will be 3A by 2 and root 3A by 2. Another coordinate, similarly, If I know this, then I know this length 3 by 2. Similarly, after doing some mathematics, same here, doing it here at this point, I can estimate the coordinate of this point, minus a by 2 and root 3a by 2. This one I can also estimate. This is a root 3a. This is a0. So the vector, should not erase it. Just keep it in some corner, maybe here. And now the vector b1 will be what? A minus a by 2. Okay, let me write it like this. A root 3a minus a by 2 root 3a by 2. So this will give 3a by 2 and root 3a by 2. Similarly, b2 will be minus 3a by 2 plus 3a by 2 and minus root 3a by 2. These are my b1 and b2. Now I know the b1 and b2, these two vectors. All I have to do is b1 cross b2 and that will give me the area. So area of the zone will be A is equals to b1 cross b2, and that will, let's do it. I, j and k, 3a by 2, root 3a by 2, 0, 3a by 2 minus root 3a by 2, and then 0. If I do it, it's a modulus, so k cap 3 root 3 minus 3 root 3a square by 4 minus 3 root 3a square by 4. Since it's an area and modulus, so if I do it, it will give me 3 root 3a square by 2, then k cap. So if I have to write the area, so the k cap says that the area has the direction which is going outside basically. So it defines, but if you take the modulus, that doesn't make any sense, then k cap, the direction also loses if you are just looking at the magnitude. So this will be the magnitude area. Let's see if there are any option. So there is an option which is number 4, 3 root 3 a square by 2. So this is an option, correct option for the given question. Let's revise it. The given lattice is of graphene, which is a two-dimensional material. Yes, it do exist in real life, and there are ongoing research in this system of the graphene, being ranging from quantum Hall, fraction quantum Hall, anomalous Hall effect, ferroelectricity, and it has shown a multitude of the physics. And in this system, just by twisting the two layers of the graphene with respect to each other, putting it on an HBN which has a similar structure, one can generate more structures. And there also people have seen one can modify the real space periodicity, like we will be studying in the Bloch theorem class, as you have studied already. So the potential modulation can be done, and that also gives some fascinating physics where the band structure gets modified. And in those band structure, ranging from superconductivity, Mott insulator, there are Chern insulators, all those things have been observed experimentally, and theoretically also they are very well explained. So that's why these type of questions are important. And with this problem, we also understood what the primitive cell for the graphene, and this B1 and B2 are the reciprocal lattice vector. Okay, if this question is clear to you, then we'll move on to the next question, which is saying that continuing with the previous problem number 3, that the sum of the graphene, the Bravais lattice for this array is A. Okay, so they are asking what is the Bravais lattice. So the Bravais lattice will be a The Bravais lattice is what? A lattice. If you translate it, basically, you can generate the the same lattice which is there of the graphene, and if you put the basis, you will generate a crystal structure. Basically, basis means if you put the carbon over there, that will give you the graphene lattice structure. So graphene crystal structure. So lattice. So let's understand the term. So lattice is periodic arrangements of points in space, and basis is something which sits on the lattice points. It can be an atom, molecule, or an object. It can be anything. If one combines lattice plus basis, that gives the crystal structure. That gives the crystal structure. In this case, they are asking what the Bravais lattice. Okay, then comes the Bravais lattice. It is a lattice which has translation symmetry. If you ask me this question, then this question itself is somewhat of, I would say, graphene is not a Bravais lattice. The reason why it's not a Bravais, because in a Bravais lattice, your R will be n times A1, n1 times A1, n2 times A2 plus n3 times A3. Yeah, R is your like translation vector basically, and n1, n2, and n3 are integers, and I belongs to Z, and ai's are the lattice vectors. So if you can translate it and you can generate the full lattice in space, for example, if you have this square lattice, I take it square points, if I take it and I put it here like this, I take it the test. Test. And this is going like all across the space, extended till infinity. Let's assume that it's extended till infinity. And these, whatever the structure you are seeing is the lattice points. Then I can choose a unit cell. It can be like this, be it A1 and A2. If I translate it by an integer, this thing, and I move it to some other place, which is also by integer, which will be how much? This is A1, this is also A1, this is also A1, this is also A1. Right? So it will be translation of 3A1 plus how many A2s? 1 A2 and 2 A2 plus 2 A2. You will generate the similar structure. So this A and B will be equivalent. Right? If you do the translation by integers numbers. Here this one is an integer. This is also an integer, belongs to Z integer. That means that it's a Bravais lattice. But in the case of the graphene, If you ask me the primitive lattice, then yes. Instead of the breve, if you ask me the primitive lattice for this array, yes, this I can answer. But graphene itself is not a breve lattice. Why so? Because if you have this thing, this structure, this structure you have, I can translate it in the X. I can generate these ones. Yes, I agree. I can generate these ones, but I can't generate this one if I do a unit translation. So this won't be generated, right? These won't be generated. This can be generated. So it's not a breve lattice. It's the primitive lattice you can ask. The word the primitive lattice, and yes, that can be answered. And in that case, the primitive lattice is what? The Wigner lattice basically. The primitive is the Wigner. So it will be made up of B1 and B2, right? Let's look at the options. It will be a rectangular lattice with basis vector D1, D2. No. Rectangular lattice with basis vector C1, C2. No. Rectangular lattice with base vector A1, A2. No. Rectangular lattice with the basis vector B1, B2. Yes, right. This is right. So the option number 4 is right here. Yeah. Any question or doubt you can ask. I'm happy to answer it. If no question is there, then I will move on to the next question, next problem, which is, as you can see on the screen, Bloch theorem is about the wave function of an electron in a periodic potential. It is stated as psi x of x plus a will be psi x e to the power I k a. That is, wave function at a position x plus a, where a is the lattice constant. I think that's what they mean. Periodic potential constant will be psi x e to the power I k a. E to the power I k a will be a phase factor. Which of the following is also an equivalent form of the Bloch theorem? So they are saying that which of these will be the equivalent form of the Bloch theorem. So let's just solve it. The given is psi x plus a, psi x e to the power I k. To see which of these is equivalent form, equivalent form, we will have to substitute given options in equation A. Equation A is psi x plus a is equal to psi x e to the power I k a. Let's substitute the one. Psi of x is, let's solve like option 1. U of x e to the power I k x plus a. Here u k ux is periodic potential, periodic crystal potential, periodic crystal potential with u of x plus a is equals to ux. That's what is given. Let's substitute this. So if I replace the psi x plus a, then u x plus a e to the power I k x plus 2a. So this is my question number I1. So let's substitute this equation 1 and 2. Substitute 1 and 2 in A. Psi of x plus a is nothing but u of x plus a e to the power I k x plus 2a equals to u of x time e to the power I k x plus a, u of, it's given that u of x plus a is ux, so I can replace this ux plus a equals to ux. So I will write it ux e to the power I k x plus a times e to the power I k a equals to ux e to the power I k x plus a. The term which is here, this term, and the term here, they are same. So this tells me that e to the power I k a is 1, but it need not to be. To be for all k. What does this mean? This means that option number 1 is not right. It's not equivalent to Bloch theorem. It's more equivalent to the periodic kind of the points. Now the option number 2 will be psi of x u of x e to the power I k x. Let's just substitute this. Okay, let me just first write psi x plus a. In this case will be u x plus a e to the power I k x plus a, which I can write u e to the power I k x plus a. This will be equation number 3rd. This will be equation number 4th. Substitute. Third and fourth in 1. What does this give? This gives me u. So the equation number first is psi x plus a ux e to the power I k x plus a. That's what it is, right? Let's just substitute psi x plus a. So u e to the power I u of x is equal to power I k x plus a ux to the power I k x plus a. And this is true. The left is equals to right. LHS is equals to RHS. This means option number 2 is correct. Now let's rule out the other options. So option number 3. Option number 3 says that psi x plus a is equals to u of x e to the power I kx. This is my question number 5. Substitute directly 5 in equation 1. This tells me that u of x e to the power I kx equals to u of x e to the power I k x plus a. This gives me e to the power I k is equals to 1, but it need not to be. To be for all k. This is also not correct. This means it's not correct. Option number A is also not correct. This is correct. Let's check out option number 4. Psi of x plus a is equals to u of x plus a e to the power I k a. So if you look the number 4 term, psi of x plus a is equals to u of x plus a e to the power I k a. So this can be written as u of x e to the power I k a. This is my question number 6. Substitute 6 in 1. And what we get is u of x e to the power I k a is ux e to the power I k x plus a. This gives e to the power I k x is equals to 1, which is not true. So this is also incorrect. Incorrect. So the correct options which survives in this case is the option number 2, that is psi of x is equals to ux e to the power I k x. Okay, so this is the question. If anyone has any question or doubt, they can ask in the comment box. I'll be happy to address your queries. If no questions, then I will move on to the next problem, which is like this. When we impose boundary condition on an electron confined in a quantum well, only discrete value of k's are permitted. We know that, and we also know that what are the k values. These are n pi by l, right? In a 1D box, we all know it's the classical quantum mechanics problem. Now, when we impose periodic boundary condition on a string of n atoms, how many discrete value of k are there and what is their spacing? This is a good question. So what it says is like you have a string which is of length. This is 0. This is L. Now it's my choice. I can modulate it and I can make it a ring. So this is my 0. And this, the same point is my L. So I will call it 0 also and L also. And that's my choice. I can define the problem like this. Nothing stops me. Right? Now, when we impose periodic boundary condition on a string of n atoms, how many discrete value of k are there and what is this spacing? So there is a string which is of length 0 to L. So 0 and L are equivalent point. I don't see any difference in them. I bring them and connect them together and make a circle. So that tells me psi of 0 in a periodic boundary condition, we know, right? Psi of x is u of x e to the power I k x. So psi of 0 will be u of x, that is u of 0 e to the power I k 0, and psi of L will be u of 0 e to the power I k L. Since the two has to be same, this is the psi of x at x is equals to 0 is equals to psi of x is equals to L. This implies, and u of 0 is u of L because there is no difference in, and u of 0 is equals to u of L because there is no difference between 0 and L point. Then in that case, e to the power I k 0, that is 1, equals to e to the power I k L. This tells me that k can only have the discrete values, which can be written as kl has to be 2 m pi. The m belongs to integer, and that gives me k to be 2 m pi by L. So this is something. And since there are n atoms and discrete atoms which are spaced by a. So this is like such n. So and this spacing is a. The total length is na. In that case, I can write the L to be 2m pi by na. Right? Now the question comes: m belongs to integer, but how many values an m can take? Right? So the question lies here that if the wave function at this point 0 and L has to be the same, then it can have one node in between. What does it mean? Is like, for example, if I straighten the point 0 to L, this kind of wave function, this is psi of x. At 0 and L are not same because d psi by dx at x is equals to 0 is not equals to d psi by dx at x is equals to L. So this is not right. The minimum possible one which is allowed is has to do something like this. No, second. Copy, paste. It has to do something like this. And then you can paste and rotate it. Yeah. So minimum, this is my 0, this is my L. And this we all know is lambda. So lambda can't be larger than the maximum lambda which is allowed is up to of length L. So in that case, the k is 2 pi by lambda equals to 2m pi by L. This implies m by L is equals to 1 by lambda, and L I can write as an A. Then let me just okay. So the m can take values which are like 0 plus minus 1 plus minus 2 up to it goes up to the point where the totals are n, right? So it can go up to the point where the total will be n by 2, and in that case the total states will be n by 2 from plus minus, so that will be n by 2 minus n by 2 to plus n by 2, and that will be total states will be n. This implies total states equals to n, and the question asked is What is the spacing? So recall the equation number 1. Recalling equation 1. K will be 2m pi by NA. M is equals to 2 minus 2m pi by NA. M is equals to m plus 1. Let me write here, m goes to m plus 1, and that's what the adjacent means, right? And that will give the k delta k to be, let me write, m goes as n plus 1, m is equals to n. It will be less confusing. So that will be 2 pi by NA. Total number of states will be n. Total number of the spacing between adjacent states 2 pi by NA. Let's see if any option is there. Yeah, and discrete values with spacing 2 pi by NA. Yeah. So this question is done. If you have any question or doubt, you can ask in the comment section. Now moving on to the next problem, which is consider two hydrogen atoms with zero energy. E0 is equals to 0 and hopping term T is equals to -1. Change the ground state energy after allowing for hopping. Okay, so that's what the question is. So what the question says is that there are two hydrogen atoms with zero energy. Let's say that the wave function of the first hydrogen is phi1 and the wave function of first hydrogen atom, and psi2 is the wave function of second hydrogen atom. Cool. Now, what the question says is that phi1 times h phi1 is epsilon 0, and phi2 times h phi2 is also epsilon 0, and that is equals to 0. Now, the question also says that the hopping amplitude, that is phi1 h phi2 is equals to t, and that is equals to -1, and similarly phi2 h phi1 is also t, that is equals to -1. So the two hydrogen atoms were there with initially E0 is equals to 0 and hopping term -1. They change the ground state energy after allowing for hopping. Okay, initially they don't allow the hopping, so the T was 0, and in that case the energy was 0. Now they have allowed the hopping, so the T is finite and T is equals to -1. Now they are asking, question is asking, what is the change in the energy? Let's say initially the spin for this one is up and this one is also up. I don't have any issue. For both the functions, the spin was up. Or I don't know. The spin was random. Spin is just, how would I say that spin is up? I don't know. Some spin is there, either up or down, with equal probability. I don't know. So the system itself will choose. I am no one to choose whether the spin is up or down. Depending on the energy requirement, the system will choose. Now change in the ground state energy after allowing the hopping. So how do we compute it? First we'll have to schema and real lecture. Yeah. Sorry. So how will you compute it? So first write the Hamiltonian. H will be what? H will be, you can write phi 1 H phi 1 phi 1 H phi 2 is the expectation value of H phi 1 phi 2 H phi 1 phi 2 H phi 2. And if you do it, we have seen that this value is nothing but 0, 0, and then minus 1, minus 1. So let me write epsilon 0, minus 1, minus 1, epsilon 0, which I can write as 0, minus 1, minus 1, 0. Now, to compute eigenstates, because the eigenvalues will be the eigenvalues. To compute eigenvalues, because they will be the energy states. It will be determinant of H minus ES will be equals to 0, where S is an identity matrix. So if I do it, it will be minus E minus 1, and determinant is equals to 0. That gives me E square minus 1 is equals to 0. That gives me E is equals to plus minus 1. So now, initially, the energy was 0. E is equals to 0 when atoms were far apart. Hopping amplitude equals to 0. That's what the hopping amplitude T equal to 0 means. That the atoms are very far apart. The electron cannot jump from one state to another. But after doing it, it gets split into two. So the total energy will be 2 times E, right? Because it for one electron, it will be like this, up this spin, or the other will be the down spin, or it can be up, up. I don't care. So that's what it is. Now for this system, what will happen? It will go on seeing the two different states, with one with energy plus 1, that we call the anti-bonding state, and this is the bonding, which is equals to minus 1, is equals to plus 1. So since there are two electrons which can sit here, it's like this and like this, so the total energy is to 2E is equals to minus 2. Now the question asks us what is the change in the ground state energy after allowing the hopping. So initially the energy was 0, initial, and this is final. So what is the change in the energy? This was 0, this is 2. So change in energy is 2. That's what. So the answer will be here 2. Ideally it should be minus 2. The change, the final minus initial, it will be minus 2. Okay, that's the answer to this question. Okay, fine. Now moving on to the next question, which is about the translation operator Tx. So T is a translation operator which is defined as given in the question. If it gets operated on a state which is a function of position x, then it will translate the position by x plus a. That's what it means. And if a is equals to 0, then it will be x itself, right? This means the t of 0 is equals to 1. That's what is given in the question. Now, the question asks which of the following is false. So we'll have to deal all of these one by one. Let's start with the one. TB is equals to TA plus B. So we'll have to verify it. How do we do it? Let's operate TB on a function which is a function of y to go up anywhere. Just operate it on x. So what it will give me? TA x plus B. If I operate it again, it will give me x plus a plus b. And this I can write as TA plus b operated on x. So this means it is true. Option A is true. 1 is true. But we have to look for the false. Now, option number 2, TA inverse is equals to TA. So how do we verify it? Let's just operate TA on x. That will give me x plus a. Now, multiply it with the inverse on the both sides. If you do so, TA inverse TA x will be TA inverse x plus a. So TA inverse TA will be 1. That's what the inverse means. So x is equals to TA inverse x plus a. This implies TA inverse is equals to t minus a. But this gives TA inverse equal to TA, so this is false. Option 2 is false. So this is the correct answer for this question, but we'll have to rule out the other also. So I will do it for the completion process. TA TB is equals to TB TA. Let's just operate it on a function. TA TB will be operated on x will be TA x plus b, and that will be equals to x plus a plus b. But I can again write it as t b x plus a, and then I can write it as tb ta x. So if you compare this part and this part, this gives you ta tb is equals to tb ta. So this is true. Now this is also true. The fourth portion, if you see, this is the same one, the fourth one with a slight difference. So I will copy it and paste it here. We'll modify it accordingly. The question says is TA inverse is equals, the option says TA inverse equals T minus A. That's what the option says. And we also get the same. So this means option 4 is true. This means 1, 3, and 4 are true, and second is false. So the correct answer for this question, since this question is asking about the false, is D, second. Yes. Now, if there is any question, you can ask me in the comment box. I'll be happy to address it. If no more question is there, then I'll be heading toward the next question, which of the following expressions represents the density of state for free electron in a one-dimensional solid of length L? So, answer number 9. That's what I have to solve. Just a second. Yeah. So the option number 9. Which of the following, the question number 9, sorry, which of the following expression represents the density of state for free electron in a one dimensional solid of length? So the length of the system is given L. Okay. So the total, let's for density of state. I think in this question they are asking per unit volume also. I think that's what they're asking, density of state. Generally, that's what it means, the density of state. Okay. So that will be dN by dE, number of states per unit energy. So first we'll have to calculate the number of states, then we'll have to divide it by the unit energy. That will give me the density of state. So total number of states will be given as one state will occupy, in the case space, one state has to occupy an area of 2 pi by L. So 1 over 2 pi by L. If the system is spin degenerate, then multiplied by 2, the degeneracy factor. And each space will occupy, in the case space will have to integrate from 0 to kf. That will give me the total number of state, and this boils down to kf by pi by L. So the total number of states is equals to L kf by pi. So number of states per unit length will be n is equals to n by L kf by pi. This is my equation number 1. So let's just divide it, dn by dk. Kf will be nothing but 1 over pi. That's my equation number 2. And if E is a function of kf's, E is a function of E is a function of k, this implies del E by del kf this is my question number 3. Will be some quantity del E by del kf, will be some quantity, I don't care. But why? What do I care is dn by de. De at k is equals to kf. Or dn by de at e is equals to ef. So this I can write as dn by dk times dkf by de at k is equals to kf. Substituting equation 2 and 3. Density of state d epsilon will be 1 over pi del kf by del e, or I can better write it as del k by del e at k is equals to kf, or I can write it as 1 by pi del e by del k at k is equals to kf, or 1 over pi del e by del k at e is equals to ef. Let's see, any option is there? Del e by del k at e k is equals to e. Where is that Fermi function? Actually, need not to be k is equals to k. K is equals to just k. Need not to be k. Just it can be like this also. That's also true. So e, it will be a function of k, and then ek is equals to e. That's also true. That's also true, and that matches the option number A. 1. So that's the problem number 9, which I have solved. Now moving on to the next problem, which is problem number 10. Hamiltonian is given p square by 2m plus ux. So p square by 2m is the free particle part, and ux is the part which confines the electron in a periodic potential. U of r plus a is equals to u of a. That means that r is the periodic potential in the system. Tr is the translation symmetry operator. That means it translates from one point in the position. Then which of the following is true? Okay. So yeah, momentum has okay. Let's start. H is given p square by 2m plus u of x, where u of r plus a is equals to u of a, periodic potential of a, periodic potential of periodicity r. E capital R is the translation operator. So basically, if t of a is operated on something which is a function of x, for example u of x, then it will be u of x plus a. That's what it means. Maybe it is operated on something. In this question, this should be like this: u of r then in that case it will predict potential, and ux plus a can be written as u of x. That's what the predict potential mean. Yeah. So the first question says TA and H are not commuting, do not have simultaneous. So we have to first see whether they commute or not. So TA and H commutation. So this will be TAH minus HTA, right? Operating on any function which is psi. So the first thing is like in Hamiltonian, TA operated on H will be nothing but T square by 2m, because momentum doesn't change, u of x plus a, and that will be T square by 2m plus u of x. That will be equals to HTA. This implies TA and H commute, and they have the simultaneous wave functions. Okay, so the option A is false, option second is true. Now coming to the third question. The simultaneous wave function can be understood like if the two if the two operator commutes, then they will have the simultaneous wave functions. You can get it from determinant of H minus ES, the way you determine the eigenvalues. Or there are the fundamental, like the Griffiths book you can read about for the more detailed understanding. Now the option number 3, I will check. TA and P is equals to 0. TA, P and H have simultaneous wave function. Okay. So P, we know that X and P don't commute with each other. IH bar. They don't commute. They are not equal to 0. So TA and P, TA is translation operator. It commutes with P. This section is true. This is true. But TA, P and H have simultaneous wave function. This is false. Why? Because P doesn't commute with H, because H has function of X, and X and P don't commute, they give a non-zero number which is IH bar. How you can get it? P you can write as minus IH bar d by dx, and then you can write X P minus PX basically. So X minus IH bar del by del X minus 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 plus IH bar basically, and if you just operate it on something which is not a function of x, for example, so, okay, sorry, I did a mistake here. Sorry. X minus I h bar del by del x minus I h bar del by del x of x del by del x, then the operator x which gets operated on function psi. So this will be minus x I h bar del psi by del x minus I h bar. First it operates on x, so it will be I h bar psi. Then it operates on I h bar del psi by del x. X comes out. is equals to sum of the Hamilton, the expectation value of it basically, and times the psi. You compare it, these two terms cancel out, and this gives I h bar psi equals to this term, the psi, and this term. That's that the expectation value of this operator is this. This tells you that x we don't commute, and that gives I h bar. X and px, I should write x and px, not the p. Because if it is py, then they can compute, of course. But since in the Hamiltonian, it's not mentioned whether it's px or py, so I assume it to be a combination of px, py, and pz maybe, and then it won't commute. So this part is true, but this part is false. Yeah. Now in the next option, p and h is equals to 0. This is the false. Why? Because h is a function of x and p do not commute with. Okay, let me write it here. Okay, let me write it detailed. Okay, the same thing is better I'm saying. This implies EA and P commutes, but TA, but P and H can't. The same thing, can't commute because H has U of X and Px is not equals to 0 and is equals to IH bar and is not equals to 0. This tells me that H and P will not commute, and that's what the option number 4 is. 4 says that they commute, but they don't commute. And TA, P, and H. So here, this part is true. This part is true here. This part is true. But here, this part is false. In this one, this part is false. This complete false is false. Here, this is completely true. This is also true. So the option number 2 wins. And option number 2 is the correct answer for this question number 10. That's what it means. So just a quick overview what we did in this class. So we started with a problem number 1, which is a linear combination of 3 different wave functions phi i's basically, and we calculated the expectation value of the given Hamiltonian like this. This turns out to be 22 by 8, 11 by 4, and the correct answer here is option number 2. The next question is the following probabilities can exist as a face-centered unit cell. The orthorhombic, because monoclinic it cannot be possible in the tetragonal. The face-centered cubic basically translates to the base-centered and body-centered, and then in that case it's the face-centered is not possible, and the body-centered is the one which leads. In the question number 3, the graphene lattice structure was given, honeycomb lattice. The question asks what is the Wigner size unit cell in area in the cell. So this will be the P1 cross P2, this area basically. So that's what we had to calculate. A is the nearest carbon distance. So we calculated it, and A turns out to be this 3 root 3 A square by 2. In the next problem, continuing with the previous problem 3, the lattice of graphene, the Bravais lattice for this array is, I think it should be primitive lattice, and because Bravais is not possible in the graphene lattice, the kind of the thing the graphene lattice is made up of two Bravais lattice which are like rotated with respect to each other, and it's made up of two Bravais lattice. It's not a single Bravais lattice. So one should ask what is the primitive lattice basically in this case, and that will be this one made up of the B1 and the B2 that we discussed. This is the primitive one out of the given options. The next question was Bloch theorem was given, Bloch theorem relation was given, and the similar equivalent form of the Bloch theorem was asked. So the option number 2 satisfied, other did not satisfy the equation, and that's why the option number 2 wins here. Then there was a problem in which there was a string 0 to L length with a periodic potential of A, and the question asked like how many number of states will be there and what is the spacing between each of these states. That turns out to be the total states will be n, and the spacing will be 2 pi by na. That gives the option number 3 to be the correct answer. Now there was two hydrogen atoms with the ground state energy given as 0 and hopping terms t equals to -1. The question asked what is the change in the ground state energy after allowing for hopping, and that gives 0, 0, -1, -1. Basically, this is the question. We calculate determinant of H minus ES. E is equals to plus -1. The both the electrons will come in up and down spin in this state, and energy will be -2. Initially, it was 0, so the change in energy is -2. So that's why this state is more favorable, and the atoms forms the molecule. The translation operator is given. That's how the translation operator is TA, which is the following is false. We saw that 1, 3, and 4 are true, so and the second is false. So that's what the second is the correct answer for this question. In the question number 9, which is the following expression represent the density of state. So we calculated it, and the option number 1 satisfied it. 1 by pi, 1 by pi multiply 1 by del E by del K at E K is equals to E. E is equals to E K, or whatever you say. Now the next question was H is equals to P square by 2m plus Ux. Basically a particle in a periodic potential. They say it should be U of R plus H equals to U of R. This question should be slightly modified. And TR is the translation symmetry operator, then which is the following is true. Then we observe that 1 is false, 3 is false, 4 is false, but the second is true. That's why the option number 2 wins. And with this, I'll conclude the class. If you have any question or answer, you can write in the comment box. I'll be happy to address your questions. So